Where are we? There we are. Hi everyone. Welcome back. Turn the music up just a little bit. There we go. Turn myself up a little bit more. There we go. Should be some nice background music now. Awesome. Cool. Hi everyone. Hope you're doing well. It is really hot where I am. So that's a thing. Hope that everyone's managed to stay cool in this weather. And apologies for not being here last week, but I was away, and I will be away next week as well. So this week, just trying to squeeze in a live stream, try and keep everything on track to avoid the long periods in between as we had earlier in this series. So first thing to do, check where we got to, and we're now using Tori. So we use cargo Tori dev instead of trunk serve as we did before. And we wait for it to build. And when it loads, we can see where we're at, and I'll tell you what I think we can realistically achieve this week. Okay, and it loads up on this page. At some point, we are going to have to address the fact that the menu is garbage at the front of the landing page. I was hoping to get a bit further down, but I would love to have a 3D scene behind. Big fan of Half-Life games, as many people are. And one of the things they did was that they put all of their menus on top of actual like rendered 3D scenes. And those scenes changed as you move through the game. So like the point that you were at, which I thought was really cool. So something a bit like that, probably nowhere near as advanced as that, but still, there we go. So what let's do. So yeah, we centered the points, and we can now fire firebolts, and they don't look too ridiculous, even though they don't turn, and they move kind of fast. We can move from side to side, obviously, get the perspective. So we need to fix the sky, and I think that will probably be the first thing that we do. Yeah, I think we'll fix the sky, and then I'd like to animate the guy, the little man, because at the moment he just rotates and moves. He's completely static. I'd like his arms and feet to move, and then once we've got that going, then I think we can start to add in the hitboxes and make him explode and give him health and all the sort of usual things that you see in games. But yeah, we can see we can hit the things. I think at some point we're probably going to have to address the hard-coded boundaries as well, and replace those with colliders, which means that instead of saying when it gets to the end of the room explode, that actually we'll put a proper collider on that back wall, so it'll explode when it hits that actual object. And it means that we can start to give each of the 3D objects that we have in our scene a physical presence, and sort of just make them interact around that. So right, so first thing to do, we will move that over onto the other screen. Say skybox, yes, that's what we're doing. So that is, I think, is part of the background. Did we create a background? Well, I guess the easiest way to find it is going to be to look inside the assets folder, find the texture that we're using, which was it's not sky, but starry sky. There we go. And we'll just search for starry sky. And there we go. It's in here. So this is night sky. And I think we're going to have to turn night sky into a vector of models. This will probably be quite useful for later because we can reuse it. We'll be able to reuse the skybox model for other rooms that are bigger or have more exposed sky, and then just create a vector of night skies. So, and that obviously is notice that we've got sky. So, we want to do 4 night sky, night sky. There we go. Yep, that's That's great. Let's figure out exactly what we want to do. It's just to loop through each one and realize that we want to do the same thing for the render as well. So then we want to create another one. And actually we want all of the items are going to be the same. So let's mute night sky equal to vec new. And if we set that to that, it should be able to figure out the type. And then we're going to create a function called add night sky. Or no, actually, we'll get night sky. X, F32, Y, Z, and returns a model. Cool. There we go. Yeah, so all we've done is we've just made these into variables and we put them here. We can see the scale in the Z direct. Wait, hang on. No, it's the Y, I'm sure. Well, let's have a look. We'll set it to 20 first. So night sky dot push night sky 000. Yep, that's where the first one goes. And then we want to do night sky push and oh, minus 20. There we go. It's figured it out for us. And we'll reload that. And so we can see that it's put it in the floor, which is great. And that's because I forgot to set the this to 40, which I think is where it was. Both of those will be 40 because that's how high up in the sky they are. No, oh no, that was the scale. Oh. So I'm actually going to have to check in on what the original value was. The original value, it was 8 high and 18 deep. So if we switch back to here, it needs to be 8 high. And what did I say? 18 deep. No, 20 deep. No, hang on. Wrong one. Yeah, it was 18 deep. So this one needs to be 18, which then means that needs to be -2, I think, depending. But we shall have a look. Okay, cool. So we can see that those are overlapping because we're doing some tearing artifacts as we move. So my assumption was wrong, and this needs to be 18 minus 20 minus another 20, so that'd be minus 22, I think. And then that reloads, and we can see that there's no gap, which is great. And it's we've now got none of the green left. Although, yeah, I would point out it is fairly obvious that the skybox is just that it's looks like a painted ceiling rather than an actual night sky. But everything's got a bit of a sort of indie feel to it in this, so I think we're okay. That works well. At least we can't see the sky anymore, so that's great. Okay, so the next thing to do is to so the way that I thought of debugging the little man and his animation is that we're going to need the camera to follow him, which means we're going to have to break from the usual perspective and instead set the camera to track wherever the little man is. And I'm going to have to remind myself where all those different pieces are. Okay, so enemies are here. So we need to get the position of the first enemy whenever it updates. There we go. Oops. Just leaving this here so it's easy to figure out what to comment out after we're done with it. So let pos equals self get location. Great. And then we want to enable camera movement. So we're just stopping the camera from moving there. And we want to put this here. So we want that to be pos.x and pos.y plus, let's say plus 2 for now. Then we want pos.z at minus 2.0. So I'll just do that. I know this is going to go wrong as he moves, but I just want to check that it's tracking his movements. It's rotating. Yep, cool. Okay, so it is working, but it's still looking at 0, 0. So we also have to tell it to look at, I think, yep, there we go. So the look at, so come on, look at, yep. So we also need to comment out this bit as well. And we want the look at to be the just the position. So pos.x, pos.s, yep, okay, great. Oh, we have a build failure. Why do we have a build failure? Okay, yes. So we want, yeah. So the debug was relying on this variable, and we just commented that out. So here we go. We're now tracking the little man as he walks around, which is actually pretty cool. I quite like that. And then presumably he's going to come back down the room. Yeah. Okay, just going to leave this for a second. So I clip this, put it on the, stick it on Mastodon. So that looks quite cool. Also, I'd like to do a before and after, so that as he's walking around, because I want his arms and his feet to move when he's actually walking. So move that back over here. Cool. So we've got our debug system set up, and now we can edit the enemy model. Characters, enemy. So we are going to need to hold on to each of the rotations of each of the positions. So let's start with the feet, and that's going to be F32, F32, and it's just going to be the offsets forward and backwards, and we'll make them. Oh, that's an idea. Yeah. Maybe. Yeah. So the problem is, or the thing I'm thinking, if you'll bear with me, I'll draw the. So we've got our 2 feet like this, and as they lead, we want one to go forwards and one to go backwards. And then once we get to a certain point, we want them to come the other way again. But I've actually thought of a little hack. We can use a sinusoidal function. We will, and we'll just offset them. So we will, yeah, so we'll just simply use sine, and that'll give us actually a nice smooth in and out. So let's have a look at that and see how it works, and we'll offset them by 90 degrees. So as one starts to go forward, the other one starts to go backwards. So it should, yeah, that should work. And we should be able to do that by using the yew time, which, let's see if that's actually passed in. It is not. Okay, so actually we will maintain an animation timer 32. Under rotation, animation timer set to 0. And in the updates, if do we have a state? We don't actually have a state yet, so it doesn't know what state it's in. Okay, interesting. Right, so we will have to figure out the state because it will be moving. So that's setting a new destination, that's fine. At that point, we will set self.animation timer to 0. So we'll reset that whenever it gets to the point that it gets to. Then, if the rotation angle is not the same, so this is it. You know what, I'm going to reach the destination, set a new one. And leave little notes here, because obviously when you come back to it, you need to figure out where we're at. So, yeah, rotate towards the angle, it's got that, and this is, we are facing in the right direction, and can move towards the destination. So then, we call self animation timer plus equals delta. And the shoe offset, there we go, nice. So this was, now I have to remember what each of these magic numbers is that I've left here. So the -3 is just the position and then down, so that puts it on the ground, that's fine, that doesn't need to change. But the position Z, it's the shoe offset, that's the thing that needs to change. So the X means, so if it's cos, it means it's offset, so when it's at 0. So if you imagine, we'll go with the right foot for now. So it's 0.0625, call that theta. Theta is 0.625. So that's how far left it is. Sorry, left or right. And then this is how far forward or backward it is. So at if the usual rotation it would be yeah, and then delta, and the delta is 0.055. So then we want to add it's forward backward equals self.animation timer dot sign times 0.05. That feels, yeah, so the 0.05 is essentially adjusting that plus 0.055. What does that want to wrap? Yes, there we go. Okay, so we're adding in our 0.55 and then adding this extra thing. So obviously at 0 it will be no offset at all, so the two will be even, and then it should so yeah, we're not dealing with the left shoe at the moment. We also need to add that in to, oh, sorry, this is the shoe offset set. Oh no, we are dealing with the left shoe. Yeah, okay, we're doing the left shoe, not the right shoe. So the next thing, let's find the model. Okay. If I bring that into frame, we can see it's moving way too fast. So that's when it when it was doing the self animation timer times 5. I think it knew what it was doing. Times 5.0. So that should stretch out the. Or is that even worse? Yeah, I think that's even worse. So I think it's actually divided by 5. Oops. To slow down the rate of change. So bring that. Yeah, it's slightly better, but it's not. We're also quite far away from this guy, so I'm going to move the camera in. Make it just 1 above. We'll have a look at where that is. Yeah, we're a little bit. Okay, I actually think it might be worth looking at the front of this guy as well. So we'll actually change that to +2. So we're on the other side of it. Okay, it's still, the shoe is still moving really, really fast. So let's enemy. So let's divide by 20. Let's make it really slow and see what happens. Okay. Yep, we're almost there. Still absolutely hammering it. So let's try making it over 100. See what that looks like. Okay, that's not bad. Yep, I'm pretty happy with that. And then we need to do forward, backwards again for here, but this time it's going to be minus, and stick that in there. And something went wrong. Yep, he's a little crooked because he's gone backwards. So I think that's actually, yeah, in fact, I broke my own yeah, so now you see he's sort of bunny hopping around. His both feet are going in the same direction. And that's because we never added the offset to the sign. So what we can do that. Offset ang. Whoa. Adding that in for. Okay, that's offset ang, but we're going to multiply that by -1. So we're just inverting that. That should, there we go. And they're now offset, so they're just pattering along, alternating away. Nice, okay. And the next thing to do is to use a similar calculation on the arms. So we'll just look at the left arm at the moment. And that would be around the X rotation. I think this is where it's going to go perhaps slightly wrong, because I think we're going to hit the same problem we did before. So I'm just going to make it like a static 90 degrees. Oh, okay, that's not too bad. So I'll show you what happens when we make that a. So we'll actually get. We'll create the angular offset. The offset angle here. So that's going to be between -1 Oops. Okay, yeah, so it's actually not too bad. That is rotating in the way that I thought, but obviously it's rotating around the center of the model and not the top part. So we're going to have to calculate the offset on that to make sure that it moves and everything. So we have to adjust for the position to make sure that the rotation is correct. Which is going to require some maths and possibly me having to break out a pen and paper or go away and think about it, which that could be the... So at 0 there is no rotation, so the arm is static, and at full it's going to be at an angle of 1, which is going to be not quite 45 degrees, or no, not quite 90 degrees. So yeah, it gets up pretty high, but not quite. 90 degrees is going to be pi over 2, which is 1.7. So yeah, it's going to be about here. And because it's rotated around there, we also have to move it forward. The amount. So we're going to have to try and remember how big the arm was. And if, yeah, we're going to have to figure out how long the arm is and compare it to the scale. Okay, so it's quarter size. And we, yeah, so we need to look up the model that we used, and that's, we're going to need the GLTF exporter. So let's see if I can find that. I think we created the models in there. The enemy arm. I did find it. Here we go. So the arm. Is so the shoulder part on the top is at 0.8, and the lowest I can find is 0.4. Sorry, minus 0.4. And the sphere is at 0.38. So yes, I think it goes from 8 to well, that's even more complicated because it's not centered. So the I'm going to create a new one of these. Nope. Don't save. So this is at 0.8 and this is at minus 0.4. So the center point is going to be although actually, are we even... We're not setting the position. Or are we setting the position like that? Plus... Yes, right, okay, it's got an offset of 0.15 in the X and Z directions. Okay, but that's... Yeah, we only need to move it forwards and backwards, so we're actually only moving it in the Z. No, it must be in the X and Y direction. Right, so the compensation will be to move it from here to here. So it's rotating around, I think, this point. In fact, let's have a look. Just see if it's rotating. Okay, yeah, so slight problem is that we can't really see from this angle. But it looks like it's actually doing it from the middle of the model, but I will double check that and we'll move the camera to adjust. So +2 and set that to 0. And that should give us a better angle. So we are now, wrong side. It should be -2. No, I was right. It is. It's rotating around this lower point here. So we need to calculate the offset. So this. We need to figure out where we want it to rotate around. So I think we want it to rotate around, let's say 0.6. Because the whole thing is 1.2 high. Yeah, so we want it to rotate around the 0.6 at this point. So we need to, when it's rotated this direction, we actually need to move it this way. And then when it's rotating in this direction, we need to move it that way. So we need to change the offset forward and backwards by the angle. So at an angle of 1, we want it to be fully forward. An angle of, so yes, the angle is moving between 1 and -1. Oh, the other thing I didn't check was whether it's moving in time with the shoe. Let's try refreshing and see what happens. Yeah, that is actually offset. So it's, so as the arm goes forward, it goes backwards. But we need to. Okay, let's have a little play and just see if we can make the arm model move forward. So this is this extra offset is to just kind of curious what happens if we set the offset angle for the X direction. No, I think we need this component on its own. Oops, calc. We don't need the brackets then. So I'll add that in. Okay, so timer calc, and then we want that's backwards equals timer yeah, let's see what that does. I think that's actually making it worse, so we will subtract the forward backwards. See if that makes it better. Yep, slightly better, but just multiply that by 10. Okay, that's too much. That's way too much. But it is going in the right direction. It's just swinging too much. So that's 0.1. That's not a helpful angle. Let's remove the skybox from the rendering. There we go. So we're just taking the walls off, basically. Yeah, there we go. Okay, so it's going up and down. Not fan of that. Why is it going up and down? Ah, right, yeah, because we also have to adjust the. Okay, so I guess let's reset that. But it's staying in the right place. That's pretty much staying in the right place. It's just it's bobbing up and down too much. So we also need to add an adjustment on the Y plane. Let up down equals so it needs to be timer calc dot sign. Yeah, this needs to be quite small. So I think that's good. And we'll just add this and then refresh this. I think that's better, but it's still too much. So let's try setting that to 0.1, see if that's the same. Okay, it's dipping down for some reason. Is that because it's going in the wrong direction? Let's try subtracting. Oops. Subtract, there we go. Nope. So adding was definitely right. It's just then it's sort of, yeah, so maybe that needs to be 0.08. Let's try a slightly smaller one. Okay, that's working. But I think I just saw another big problem, which is that when he was on a different rotational axis, it didn't work at all. Actually massively compounded the problem. Yeah, there we go. So when he's going the other way, it's rotating too far. So our calculations were wrong. Well, this is a conundrum. I just have to take a short break. I will be back in just a few minutes. Okay, sorry about that. Had to answer the phone, but I'm back now. Let's have a look. Right, so okay, so our assumptions here were not good, and I think all my assumptions were not good. So I think hello, yeah, we're firing all over the place. Okay, so I think the the best way to sort this is going to be actually going to be to set the position of the thing. So destination position. Yeah, and then when we set new destination, there we go. Yeah, it's this random one. So if self.destination x equals 4.0 and self-destination is 4.0, then yeah, there we go. So it's just going to flip-flop between two positions. And then we need to make sure that the initial destination... oh, actually, no, that's fine. Because it's just because it's an else clause, it should hit that. So it should just move between the two positions. I might need to put the wall back in to verify that's happening, but let's go. Okay, there it goes. One direction. And then rotates. And goes back again. Okay, cool. Yeah, that's... We'll just check that it gets to -4, -4. Looking at the location at the top, the enemy location of the debug statement. Yes, okay, so he's now moving between two positions, and when we calculate the camera position, it's going to be -2 times and the lot equals self times first get rotation. -2 times rot.cos and times 2 sign. Yep, so this should now pin that to the okay, nope. I got the functions wrong. Okay, that didn't... It should be pinned to the side of him, and it's just not. It's still watching. So yeah, this is very odd. This calculation is not doing what I thought it was. So the camera, we want to go to the position. So that should be whatever the position is, -2 times rot.cos. So that must be plus. I think we're going to have to put the room back because I'm a bit confused as to what's going on there. That's so put the room back in. Okay, yeah, so he's definitely rotating. It's rotating too far, the camera. Oh, yeah, okay, I made him go outside the bounds of the wall. That's even better, right? Okay. So let's set that to 2, 2, 2. Hopefully he'll stay within the bounds this time. Okay, yeah, so the rotation, it's working, but it's going in the wrong. So be standard f32 const pi times 2 minus, so it's going to be 2 pi minus the rotation. That's going to be the there we go. Okay. We are kind of there. So this should track around behind him. Yeah, okay. So this is now working in that it's tracking his rotation, so it's always staying pinned, but we now want that rotation to actually be all of that plus that's over 2.0, so we want a 90-degree offset, and this is either going to move us left or right around the model. There we go. Okay, so we are great. Cool. So we're now like pinned to the right hand side, and in a second, obviously it'll go through the wall, so I'll get rid of the wall. There we go. Okay, so now the camera's now outside the wall, and we can't see through the wall. So we will take the skybox and remove that. Cool. So we can now see the model, and we can see this gives us a nice little debug to be working on. It's about 45 minutes in. Sorry, just got to check my phone again. Okay, yeah, so my assumptions about the offset were wrong because it's compounding the problem with the rotation. So this could be an issue. So I think it might be nice to get a version that just has the floor and not the walls, so that we can see through the walls. So maybe we also generate. Yeah, I think I'm going to have to go away and think about the actual maths for how to compensate for the rotation. Which isn't to say that we've run out of things to do, but we will create the skybox. So I think we need to create a version of the skybox that doesn't have any walls. And we did that in skybox generator. We will. So I'm going to load a new terminal so we can use our virtual environment, which is inside the apps folder. Okay, so we're now inside there. Skybox, no walls. And then we just need to find the, I forget which one. Well, I guess it's anything without sandstone. That's the ceiling. Yeah, it's going to back wall. Yeah, I don't remember which one this was. But we will say I am set pixel x y 0 0, 0, 0, 0. Cool, so that should be see-through. Yes, that should be pixel. Did I change that? Yeah, no walls. Okay. Because we're actually setting solid color for everything. Which I guess we could just set that and then just not do that. Ceiling, back wall. Cut that out. Right, that's the floor. That's the one we definitely do want. That is the back wall, which is currently bright yellow. Back wall behind. And square 6, we need to get rid of that as well. So I can't remember which wall that was, but it's left or right wall. So we now do Python skybox generator. Should be given an image. Oh, it puts it straight into the assets folder. That's interesting. Skybox no walls. There we go. Great. So we can now, inside our skybox, just use skybox no walls. And we'll need to add the render back in. Now let's have a look and see. Yes, that has worked. So got all of the we've got the floor now, which we can use as a bit of a reference point, so we can see roughly where the guy is. Just make sure it still renders, even when we're no. We've got, so the problem is it's not rendering the transparency on the back wall. So yeah, that's super annoying because it's like masking it off because there shouldn't be a pixel there. I'm not really sure why, because I'm sure we added the transparency in order to we set use transparency on the skybox model so that we could see the sky through it. I think the problem is the render order, because it was never designed to... Yeah, okay, new plan. We're just going to make this a... just going to make it a plain, I think. Do we have a plain model? We do. Excellent. Right. And what shaders do we have? We have a no texture. Yeah, let's try going with that. Actually, I'm kind of curious what happens when we set the cube texture. I think it's going to look a bit weird. Oh, we actually have to set the texture for it as well. Oh, yeah. Okay, I'll show you what's happening. It is there, it's just in a really weird place. It's just sat in the middle of the room. Okay, so actually I'm going to take the skybox. Oh yeah, there you go. That's probably a good idea. Let's just use the. Oh, why is that offset in such a weird way? There we go. Debug. It's going to be 0. Oh, no, hang on. That's 40. And then we just want that to be 0 and 0. And comment that because that's not right. Okay, nice. So yeah, that's now working. We've got them walking across the starry sky. We just need that to be a nicer looking background, and we'll do that by hijacking the skybox generator and taking the floor codes, I guess. Floor plane generator, apply. Oops. So import pillow. What's the steps to the ceiling? So yeah, I think that's everything we need. Oh yeah, we need all of the image size. Okay, and finally we need the save function. I overrode the blast. Well. Plane generator. And then we'll copy this into here. So we're just telling it to use the texture from there. And then the start X is going to be just the whole image size. It's not going to be. Oh, no, wait, this is going to be 0. Start Y is going to be 0, and the end Y is going to be 1. Just want to do the whole image. So going to save a copy in the current folder. Floor plane generator. Generator. Cool. Okay, that means that we should get one here in a second. Squares and walls, nice. Okay, and that looks kind of cool. So there we go. We have a nice floor to use as a reference for next time, and I think that's probably, given it's been an hour. Yeah, I think I need to figure out the maths on why the arm isn't working, and it's the compensation to move around the rotation point. It's going all over the place, and we just need to move the center point of the the center point of the model, so you can see around here, it's the center point's just in the wrong place, and I'm not really sure why. I think we're pretty close, but I need to sit down with a pen and paper, figure it out. But I will fix the code live on stream the next time that we stream, which I might try and give that a go over the weekend if I get time, because as I say, I'm away next weekend, so that's yeah, so I won't be streaming next weekend. But as usual, I will push the codes, and in fact, actually, before I do that, I will go back to. Oh no, I think it's okay, isn't it? We can leave it like this, just following the guy around, the little guy. It's obviously, if you click, it still fires the bullets, but they just go. Not really sure where it counts as. Yeah, I guess. Oh yeah, it's still doing the player rotation, so you can still move the mouse and change the player rotation, but obviously it doesn't affect the camera anymore, so it's just a bit random. So yeah, I guess if I can get it to 0, it'll just fly down the room. We should see it. Pop in. There we go. You can see it bouncing off the walls now. Yeah. There we go. You can see it there. Okay, yeah, so I will leave it like this. I'll push the code in this state. Obviously, it's not ideal, but we are getting closer to fixing the arm problem. And then I think the next time when the arm problem's fixed, we can start to add in points where the little guy will stop, face the player, and throw a lightning bolt or something at them. Yeah, well, thanks very much for joining and or rewatching if you're rewatching on the stream. Please don't forget to subscribe and hit the notification bell, and you'll find out next time we go live. For now, though, I'll wish you a good weekend and hope that you can stay cool in this hot weather. Yeah, have a good one. Bye for now.